Hello. Today we are going to walk through the step-by-step process of solving a first-order differential equation. Our goal is to find the particular solution to the differential equation, dy over dx equals the fraction 4x minus x cubed, divided by 4 plus y cubed, that passes through the point 0, 1. Before we start, let's look at the denominator. In some handwritten notes, the 4 might look like a y, making it y plus y cubed. However, we are solving this for the denominator 4 plus y cubed, which leads to the specific solution provided in your materials. Step 1 is to separate the variables. We multiply both sides by dx and by the denominator 4 plus y cubed to get all the y terms on the left and all the x terms on the right. Step 2 is to integrate both sides. On the left, the integral of 4 is 4y, and the integral of y cubed is 1/4 y to the 4th power. On the right, the integral of 4x is 2x squared, and the integral of x cubed is 1/4 x to the 4th power. Don't forget to add the constant of integration, c. To make our lives easier, let's multiply the entire equation by 4 to clear the fractions. This gives us y to the 4th power, plus 16y equals 8x squared minus x to the 4th power, plus a new constant, which we'll still call c. Now we apply the initial condition. When x is 0, y is 1. Substituting these values in, we get 1 to the 4th plus 16 times 1 equals 0 minus 0 plus c. This simplifies to c equals 17. Finally, we substitute c back into our equation to get the particular solution. Y to the 4th power plus 16y equals 8x squared minus x to the 4th power plus 17. Always be careful with your power rule integration, and remember that c can change if you multiply the whole equation. The first major step in solving this type of equation is called separation of variables. We want to move all the terms involving y to the left side with dy, and all the terms involving x to the right side with dx. To do this, we multiply both sides by the denominator, 4 plus y cubed, and also multiply both sides by dx. Notice how the variables are now completely isolated on their respective sides. This sets us up perfectly for integration. A common mistake at this stage is forgetting to group the terms in parentheses, which can lead to errors when we integrate the entire expression later. Now that we have separated the variables, we apply the integral to both sides of the equation. Using the power rule for integration, on the left side, the integral of 4 is 4y, and the integral of y cubed is 1/4 y to the 4th. On the right side, the integral of 4 times is 2 times squared, and the integral of x cubed is 1/4 x to the 4th. Don't forget to add the constant of integration, c, to one side of the equation. This represents the family of general solutions. A common pitfall here is power rule errors. Make sure you are dividing by the new exponent. For example, x cubed becomes x to the 4th divided by 4, not multiplied by 4. To make the equation easier to work with, we should clear the fractions. Looking at our denominators, we have a 4. By multiplying every single term by 4, we eliminate the 1/4 coefficients. Note that 4 times a constant is still just a constant. We can represent 4 times c as a new constant. Let's call it k. This keeps our algebra clean as we move toward finding the particular solution. Be careful here. A frequent mistake is forgetting to multiply the constant c by 4. Even though it stays a constant, its value changes relative to the other terms. Now we use our initial condition, the point 0, 1, to find the specific value of our constant. This is what turns a general solution into a particular solution. Substitute 1 for every y and 0 for every x. We find that k equals 17. Double-check your substitution here. It is easy to accidentally flip the x and y values, especially when one of them is 0. Always remember that the coordinate pair is written as x, y. Now we take our value for the constant and plug it back into our equation to get the particular solution. This is the final implicit solution. We call it implicit because y is not isolated on one side. Given the fourth power and the linear y term, solving for y explicitly would be quite difficult. Before finishing, let's run through a checklist for success. Did you separate variables correctly? Did you apply the power rule accurately? Did you remember to multiply the constant by 4? And did you substitute x equals 0 and y equals 1 correctly? By following these steps, we have confirmed that the solution matches the intended denominator of 4 plus y cubed. If you had used y plus y cubed instead, your integration and final constant would look very different. Great job! You have successfully separated variables, integrated, and used an initial condition to find a particular solution. You are now ready to tackle similar separable differential equations.